Hey, third grade, this is your video lesson for 7.2. For this one, you are going to need your whiteboards and your workbooks. We are going to look at a couple problems on our whiteboard first, and then we are going to look at page 222 in our workbooks. So what we're going to do today are a few explorations lesson that are focusing on estimation and estimating dots in an array. And then we're also going to finish with looking at a quick review of equivalent fractions. So to start, we're going to do our mental math warm-up. So for this one, this will be on your whiteboard. So this is kind of like extending the facts and using basic facts to extend. So if you have 1,000 minus 500, 1,000 minus 500, you could almost think of that like 10 minus 5. So on your whiteboards, I want you to solve 1,000 minus 500, 1,000 minus 300, and then 1,000 minus 800. Solve those on your whiteboard, and then when you are done, you can start the video again. So our first one is 1,000 minus 500 would be 500. And again, that's why I said like 10 minus 5. If you make those basic facts and then you extend them to larger ones. 1,000 minus 300, think of that like 10 minus 3. That would give us 700. And then 1,000 minus 800, like 10 minus 8, that would give us 200. This also helps with estimation because when we do those estimations, we make them easier numbers, close but easier numbers. So maybe your number was like 976. That would round up to 1,000. And your number was 520. That would round down to 500. So your estimation for that problem would be 500. Okay? So go ahead and erase your whiteboards. We are going to stay on them for this next problem though. So this is our math message. So we're going to follow the directions for this, and then we are going to answer a question on how to solve the math message. So it says, Mrs. Reyes wants to know about how many tomato plants are in her garden without counting each plant. She counts 10 plants in 1 square yard. Use the diagram, estimate the number of tomato plants in her entire garden, explain how you made your estimate. So this is the picture of her garden here. The part that is kind of faded or lighter is her like whole garden. And the part that she is just counting is this 1 square yard. So think of like a yardstick. And if it was that in a square, so each side would be 1 yard. This is 1 square yard. So in 1 square yard, there are 10 plants. So how could we estimate and find our estimate for this? How could we figure that out for this problem? So I want you to pause the video and just try and come up with one on your own on your whiteboard. And then when you're ready, come back to the video and we'll go over an example together. Okay? So for this one, I wish I could hear what your estimates are. But with this, what you can do is you can kind of look at it and think, okay, so there's 10 plants in 1 square yard, which is pictured here. It looks like you could fit 3 more on here for a total of 4 square yards, right? So for a total of 4 square yards, and there's 10 in each square, you could think of it like 4 times 10. So 4 times 10. So 4 times 10 would equal 40. And our unit for this one would end up being plants. So for 4 times 10, because there's 4 square yards with 10 in each square yard, we would get a total of 40 plants. So check that with your example. Check that with your example and see if that is what is true, if that, is what you had on your example. Then it says, be prepared to discuss how you estimated the number of tomato plants in the garden. Obviously, we can't discuss it right now, but you will be discussing estimation with your teacher whenever you go to your Google Meet with them. So the last part of this is looking at this diagram, which is kind of hard for you to see digitally, and actually find the total number of plants with this. How you could do that is you could zoom in on the picture and you could count how many plants there are actually in there. So there are 10 in this square. And then if you continue to count all of the examples here, you would actually end up with 38 plants total. But our estimate was 40, which is very close to our real answer or our actual answer, which would be 38 plants. So that's how you know your answer makes sense when it is close to your estimate. If our estimate would have been 60 and we really only counted 38, then we would need to really go back and look at our estimate or look at our answer and make sure that they are both correct, because when they are correct, they should be close. So for the next part, I know at the beginning we said we were going to do page 222 together. We will quickly look at that, but I actually had to convert it to a digital lesson. So we are just going to have to do it together on the Google Slides, but we will peek at page 222. So if you open up your workbooks to page 222, what it is looking at is it is using what we did in our math message about only counting for like a small part and then using that to figure out the greater number, the bigger number. That's what page 222, it looks like this, is talking about. So what it's asking you is it's asking you to figure out how many dots there are in this array without actually counting all of them to start. Make an estimation based on using just a small bit of it. The reason we are not able to do this together is because it uses pattern blocks that you place over your book, and we don't have those at home with you. If you want to just look at it and just see what they're asking you to do, you can peek at that. But we are just going to do one together on the Google Slides on the video and then on your whiteboard, okay? So if you want to leave that open next to you, you can. But the one we're going to be looking at is this one that I have here up on my screen. So with this, what we did on here is I found a large array that I didn't count, how many there were in each section. Or I'm sorry, in the whole group. But now what we're going to do is we're going to count them in sections, and then we'll find a total for that array. So for this, what I did is I drew a square around part of the array. It's 4 by 5. So if this is a 4 by 5, part of the array, what would be the total number of squares in this larger square if it's 4 by 5? It would be 20 because 4 times 5 is 20. 5, 10, 15, 20. So if I know that this here has 20 squares in it, how many do I think are going to be in the greater picture, the total array, if just this square has 20? So I want you to think about it, maybe write it at the top of your whiteboard as what your original estimate is. On page 222, it says, estimate how many dots you think are there. So in this case, estimate how many squares you think are there. Then the next part is covering it up. So if I cover up this part here, and I can duplicate this, then it will give me a better idea at how many squares there are in this total array. So if I go like this, and I copy and I paste it, so that it's covering 20 more squares, how many do I have covered now? It would be 20 plus 20, which would equal 40. And then if I cover another one, another group, now I have 20, 20, 20, 20 plus 20 plus 20, or 20 times 3 would equal 60. So now if I know that these 3 here equal 60, and I look here, could I have an estimate now, maybe a more accurate one about how many squares there are in this diagram or in this array? Well, if this all equals 60, and I copy and paste these, and I look here, and I see that there's another perfect fit for these 3 larger squares, I could do 60 plus 60, which would give me what? What is 60 plus 60? So this one would be 120. So this would show us that there are 120 squares in this array. And if you go back to what we just started with, we only started with one of those squares. and that was 20, and we used that to help us figure out how many there were total without having to go through and count each individual square. So that's how estimation plays into it. Now check, was your estimation close? Was your estimate close to what your final answer was? And that's just something that you can think about. So moving forward with that, kind of the overall takeaway from that is just estimation, how to find that estimate, and quicker ways to solve for those larger problems without having to count every single one. The last two parts of this, I just want to talk really quickly about something called equal shares. This is something that you have heard about before, where you share two parts equally. So you have to differentiate between what are equal parts and what are unequal parts. So this diagram shows you the wholes, it shows you equal parts, and it shows you unequal parts. So just being able to recognize what is equal and what is not equal. So looking at this up here and thinking, well, of course that's not equal. Someone got a lot bigger square than the other person. Or here, this is not equal. Someone also got a larger part than the other person. Think of it like cutting a sandwich. You want to cut it right down the middle to make sure that it is equal for both parts. So it's equal shares. And the last part is just a quick review of fraction memory game or equivalent fractions. So remember, if a fraction is equivalent, it means it is equal. And when we're playing fraction memory and we have the cards in front of us, the most important part is to look at the shaded in part. Of course, the number of pieces are different. This is 5/6 and this is 6/8, but you have to look at the shaded in part. Is the total amount of shaded in of the circle the same on both cards? So it says, Nash says that these cards show equivalent fractions. Do you agree or disagree? So I want you to take a second, maybe pause the video to think about it. But are these fractions equivalent? Why or why not? So in this case, the fractions would not be equivalent. 5/6 has more filled in of the whole circle than 6/8 does. So this is not equivalent to this. Because remember, if you look here, this has a little bit more filled in than 6/8. So you would say, no, you do not agree with Nash because these fractions are not equivalent. They don't have the same amount of space filled in. So I know this video, I started off saying we were going to do page 222. We ended up not going through that. I just realized it was going to be very tricky to do digitally. So instead, we were able to do one together on the Google Slides. So just remember moving forward, estimation, how you can use that to help solve those larger problems. And don't forget those equivalent fractions. Thanks, guys.